Okay, since we're starting to get into some of the more computer portion of the class, I figured it might be at least a little, somewhat of an interesting topic, and I think an important topic to delve into of just basically what a computer is. Because a lot of students, for whatever reason it may be, are scared of computers. And especially doing the computerized drawings, they think that it's something that's beyond what they're capable of doing or comprehending. And that absolutely is not the case. Um, when it comes down to it, I think my favorite description of a computer that I've ever heard is that it's a rock that we just tricked into thinking. And that's really all this bad boy is. And while this is a tower computer, this is one of the computers just from my lab that I just took opened up the case for to look inside. They can look a little bit different. Your laptop certainly has a slightly different configuration than this, or rather a pretty big different physical configuration because it's got to fit into a tiny laptop. All of the parts and pieces are the exact same. And hopefully, when you get ready to graduate and start to work as a professional in this field, you will perhaps want to maybe buy yourself a computer that can run this stuff or these softwares a little bit more efficiently. And it might help if you know kind of what all of those different specs and things written on the websites for computers, what they all mean and what they all do. So I figured we can just look at the inside of a computer, see what it all kind of is. I'll give you some of my opinions on things with a computer. I am by no means I'm not Linus Tech Tips here, but I do at least know a little bit. I have built my own computer at home before, and I do honestly think, and I'll get to that a little later, that kind of tower computers or desktops are better than laptops purely because it's way more interchangeable. So rather than me having to buy a brand new computer, I can just interchange for new parts and pieces. But I'm going on a tangent here, so let me get back to what the heck is this thing. So this is a little bit of an older desktop. It's from 2012, I believe we got these. Yeah, so this is from 2012. We haven't changed out any parts in it, so some of the parts are starting to get a little outdated, but still, every part and piece is the same, and a computer always begins with its main brain, what is called the CPU, or the central processing unit. In this case, it's underneath this fan here, and then there's also this big metal piece that's called a heat sink, because as the CPU processes things, it gets really hot. And as it gets hot, it gets less efficient and it slows down. And so we have that piece of metal there to draw the heat away from the CPU and kind of disperse it out. And the fan spins when the computer's plugged in. This exhaust fan also then spins to just try to keep the computer at a little bit of a cooler temperature. CPUs they come in all sorts of different kind of formats. There's really two main brands out there that you could have with. You could have an Intel or you can have an AMD. Within the computer nerd community, there's a big debate on which ones are better. I really don't have a preference for either of them, though I guess all of the computers I have in here are Intel ones, and my computer at home is an Intel one. For CAD work, you want one that's like an i7 or greater. So an i7, an i9, or a Xeon, which is what these ones have. Those are really good for graphics work. If you have like an i3 or an i5, it can get work done. It's just going to be a little bit slower. So once again, if you start in the market for a new computer, or at some point in your life you will be in the market for a new computer, just kind of keep that in mind for it. And then if you wanted an AMD CPU, you would just have to Google whatever the AMD equivalent of those would be. I don't know them off the top of my head. But your CPU, that's kind of your main mother brain of your computer. And then on this one right next to it, these are my RAM slots. And so your RAM is your random access memory. And again, I can tilt it a little bit so we can see them a bit more. They come in different sizes. It depends just what your motherboard will accept, which is what this big blue square is. That's my motherboard that everything gets plugged into. The more RAM you have, the faster your computer can perform actions at. And especially when it comes to CAD work, regarding like Revit and other 3D modeling software where we do some intensive graphic things, you want to have more RAM. A good standard is 16 gigabytes of RAM. These computers have 32. So each one of these RAM cards is 8 gigabytes in each one of them. And even then, you could buy a computer maybe that comes just with 16 and then later upgrade it to have more RAM without then having to buy a whole new computer. But the more RAM you have, the faster it can perform those actions, the faster some of your renderings can go. But really going over 32, I've never had a need for with CAD work. Now, in this computer right here is the GPU, or the graphics card. This honestly is going to have to get replaced in this computer pretty soon, just because it's fairly outdated and it makes some of the graphic stuff a little bit slower. But this is what runs all the graphics in the computer. On most laptops, you have what's called, like, I think it's the Intel UHC, I want to say. It's something like that. It's just like a built-in little square in the computer. And that tends to be the main difference graphic-wise between something like a desktop and a laptop. Is that because these are starting to get a little bit larger too. So like the one in my computer at home is much bigger than this guy, and therefore it wouldn't be able to fit in a laptop. But this then helps just process all the graphics on the computer, send them to the screen, make them appear faster, and the better graphics card you have, the faster it can run. This tends to be also where a big bulk of your money can go towards in replacing just components of your computer versus the entire system itself. So last year, I replaced the graphics card in my personal computer, and it was about $700 to do, which is a pretty big chunk of change. But when it comes down to it, then I didn't have to buy an entire new desktop, which could have cost me, upwards of $2,000 or $3,000. And then you also have just your storage, which can be a hard drive or a solid state storage. So in this computer, we have a solid state one. It's right over there. I don't know if I could move it so we can see it. No, we really can't. But that's just where all my file storage goes, where the computer system itself is. So the operating system is just stored on there. All of my files, all of my software that I install, it just all goes on that card. You can get them pretty darn cheap nowadays. So storage doesn't cost a lot anymore. And then even furthermore, you can buy external storage. So because I'm constantly working like on a home computer and then on my work computer and my home computer, I really don't store a lot to the computer itself. Instead, I just have an external hard drive that I can just plug in. And this is 4 terabytes of storage. So essentially enough that I will never, ever, ever run out. But this way I can just kind of bring my files to work and to home without having to worry about forgetting anything. And so it's kind of just like a big flash drive. And then ultimately, in a very, very brief synopsis, because as I said, there's plenty of videos out there too if this is something you're really interested in and maybe purchasing a better computer or even building your own one. You can find loads out there, so I'm not going to sit and bore you with it too much. But those are the four big parts of your computer that are going on. Of course, we do have things like the power supply up here. We've got, in this case, I've got a CD drive, which is kind of obsolete in this day and age, but still. So we've got our CPU, our central processing unit, which is the big brain of the computer. They come in different kind of levels. And as I said, for CAD work, you really want like an i7 or higher. Most laptops will have like an i3 or an i5, and then they just don't really do graphic stuff all too well. But we've got our central processing unit, we've got our RAM, which then kind of just goes from one task to another one. So it kind of just, as it's going through, it does its task, it erases, it does its task, it erases. The more RAM you have, the better. You want to aim for a computer that has 16 gigabytes or more. Then we've got our GPU, or our graphics processing unit, graphics card. I'm not going to tell you any particular one that you need to go get, but if you look at some of the specs on them, you can see just how well they can perform. And like most things in the world, it's the more expensive it is, the better it'll perform for CAD stuff. But we really don't need anything, you know, top of the line. We're not trying to, you know, run Cyberpunk or anything. We're just playing around in AutoCAD and Revit. And then we have storage itself. And so this thing too, my external hard drive, it is an actual hard drive and not a solid state. So it has a little disk that spins around when it goes to find it. So the hard drive ones are much cheaper than the solid state ones, but the solid state ones, it can access files a little bit faster. So it's kind of just a little bit of a give and take. And yeah, those four pieces of metal and different other minerals just operate your computer. It's not as scary as you think. They really are a little bit more simplistic. Maybe I oversimplified some things, but that's just what a computer is. Nothing to be scared of. And I think the other thing too that some students get really scared of with a computer is that it does things they don't understand. Computers are not sentient beings. They only do exactly what you've told them to do. And so there are ways to kind of troubleshoot your way through that, and it's really just practice and doing it over and over and over again. I love computers a lot. I have spent every day of my life for what some would say too many years, but I say not enough. I'm just sitting in front of a computer, playing around with it. And if something goes wrong, you can just undo it and you can try again, and all will work out just fine. Now, without further ado, let's kind of just jump into what is AutoCAD and what does it do. So AutoCAD is a product by the company Autodesk, which they make lots of different CAD software out there. So if I go to products, we can just see some of the products that they have. And I can even go into view all products, and I could see that, holy moly, they've got quite a few. They've got 78 different pieces of software out there, and some of it is very expensive. So AutoCAD that we are going to be starting with today, it costs $1,690 per year to use. Revit, the other software that we'll start to learn about, cost $2,425 a year. And then you could even, you know, this bundles 3 different pieces of software, and it looks like they even have some more in there for kind of a discounted price. There's different software. If maybe I was doing 3D animation stuff, I could do Maya and 3ds Max. If I was doing more like product design, mechanical engineering stuff, I would use Inventor or Fusion 360. Depending on what I'm doing, I would buy different pieces of software. And while that price tag is a lot, I'm not going to pretend that $3,000 isn't a lot of money. Ultimately, if you are working as an architect or a structural engineer or an interior designer or even a contractor, and you are not having a profit margin of $3,000 a year, then you need to seriously reflect on your business practices. So while this seems like a huge chunk of change, ultimately it does pay for itself because you're not going to be able to really efficiently design things if you aren't using AutoCAD and Revit. But AutoCAD itself is kind of the first software that Autodesk really came out with. And they came out with in the 80s. So it is definitely not a new software at all, but they have added lots and lots and lots of features to it. It's primarily used as a 2D piece of CAD software, but it does have 3D capabilities, and there are different subsets of AutoCAD as well. So there is an AutoCAD architecture version, there is an AutoCAD light version, they have a web version as well, but we are really just going to use AutoCAD as a two-dimensional line work piece of software. Just because really what started to happen was as they added more and more things into AutoCAD to try to make it be this one software for everything, they realized it was just going to be too much. So rather than have one software that does everything, that's why they then branched out to having 78 pieces of software that can do specialized things. Because if I am an architect, I don't need anything for 3D animation. So there's no need for me to pay for features like that. And the other reason why they branched out to having different pieces of software is because, well, they can make more money. If you have to buy 2 pieces of software instead of 1, they can then charge you more and make more money. As a student, you have the ability to download almost every piece of their software for free with your student account. So if I scroll all the way to the bottom of their website, all the way at the very bottom of their website, I can get to this support and learning for students and educators. And sure, I guess. Don't know why you need to, but whatever. And then I can click on Get Products, and I can see a list of all of the software that they have available for free for students. If any of you guys, and so maybe this applies for some of you sustainable tech folks, if any of you guys are interested in more like 3D modeling, kind of product design things, Fusion 360 is a great piece of software. It doesn't have a lot of needs for it as far as like a big bulky computer. So it can run on almost any computer. They even have a web version for Chromebooks out there. And I just can't really recommend Fusion 360 enough. But that's, I guess, because I come from that product design background. Revit is that architecture software. One thing we'll need to note about Revit is that it is a Windows-only piece of software. So Fusion, it can be done on Windows and Mac. Revit is Windows only. AutoCAD has 2 different versions. We have regular Windows AutoCAD and AutoCAD for Mac. All of the demos I'm going to be showing you are going to be in the Windows version, purely because I don't have a Mac. They do look very different when you look at the 2 pieces of software, just kind of as a heads up. And so I'm going to sign in into my teacher account, which that should be my password. Yes, that's my password. And so after you make your student account, which I sent an email about how to do that, it had like a little demo of how to make your student account, as well as some instructions I wrote out, and then some instructions that Autodesk provided to me. And so it just kind of goes through step by step of how to make your student account, how to verify your student access for it, which, whoops, don't know why AutoCAD just popped up. But you do have to verify your student account every single year. So we can see here that my access is only valid until October 28th. And then I'm going to have to go and re-verify that I am still a teacher and I still have the right for access to their software for free. It used to not be that way. It used to be that you made a student account and essentially you could keep that student account for as long as you had access to that email address that you made it with. But then people like me were using the student software in accounts that were like 12 years old and just not paying for anything. And so now they've stopped that. So sorry, that's kind of my fault. My version of this education page does work a little differently than yours, and I'm 99% sure it's purely because I have an educator account and not a student account. So if I was to click on AutoCAD and click on Get License, it brings me to this different page purely so I could download it for like a lab. So when every year I have to update all of the computers in my lab, and I can download it to put it on the image there for that license. For you guys, when you click on this Get License or Get Products, whatever it says for you, it should just kind of have a couple of little windows pop up saying like, you know, which year do you want? Do you want a 64-bit or a 32-bit? And then it'll just kind of go through and download it for you. If we look at, before we just jump into anything, the AutoCAD for Mac version, I want to see if it'll give us kind of some pictures related to how it works or how it looks in comparison. But what's not promising is this is a screenshot from a Windows version. These are from the Windows version, so I don't know why they have this. Oh, I'm just looking at just AutoCAD. I want AutoCAD for Mac. Nope, it's just going to keep taking me just to AutoCAD. Okay, here are then some screenshots that we can look at. Oh, it's a big picture. Good. I like big pictures. Oh, and it's from AutoCAD. How interesting. So it looks like they have some videos here that go over some of the stuff that I'm going to be going over too. If I wanted to open image in a new tab. And so the big difference between AutoCAD Windows and AutoCAD for Mac is just the way your toolbars are set up. So in the Windows version, what you're going to see is that all of my toolbars are up at the top of the screen, and some of them have text underneath them or next to them to let me know what that tool is. In the Mac version, your toolbar is kind of condensed to the side. I think what they were trying to do is make it a little bit like sleek and how Photoshop looks. And personally, I just feel like they missed the mark a lot. So while I am going to be showing you guys where buttons are, I'm also going to be suggesting that you use keyboard shortcuts a lot, because keyboard shortcuts can be very, very helpful for what we are working with. The other thing too is I'm going to be often explaining things of just using your mouse. So as I said, I suggested that you guys get a mouse rather than use the trackpad on your laptop, just because it does make things so much easier when we are dealing with making drawings. So I am going to be, saying like, oh, if you hold the scroll wheel down, I will show you where some of the other shortcuts are. But ultimately, since I am on a desktop, I do have a mouse available. I am using the Windows version. Those are just the things that I'm going to kind of be showing in the demos and stuff. So once you download AutoCAD onto your computer, whether or not you're using the Mac version, whether or not you're using the Windows version, the other options that you could have too is there is a web version. of AutoCAD, in which you do have to have your student account for. My students have been using it for their homework assignments since they just have Chromebooks. But we'll just see what this looks like. It is a condensed version of AutoCAD, so it does not have all of the features that regular AutoCAD does. Your toolbars are much more condensed and over here in the bottom corner, but you still have all of the tools, you still have a properties bar, you still have layers, you have the ability to put in blocks, which we'll go over what those things are in this class. I promise, well, not in this lecture, but in the course itself. So you are still going to have access to all of those things in the web version, if you would prefer to use that web version instead. Or you can also access it through Autodesk. So if you go onto Autodesk, you can log into a virtual machine just like I explained with SketchUp. But you can go onto Autodesk, log into your ASU account, and if you go to the AD and STBE GPU lab, this lab is only available to students whose teachers requested that they have access to it. So not every student has access to it, but you guys do, which means it will run a little bit faster, which is kind of nice. But just once again, as a little forewarning with Autodesk, is that if you do walk away from it, and by walk away, it could be that you just go into another tab, you're playing around in that tab for a while, and you're not doing anything here in the Autodesk tab, it could log you out. Or if you just walk away from your computer, it could log you out. So I do recommend just kind of save your work often, save it to a flash drive that you own. Don't save anything directly here in this virtual computer, just because it does, in order to keep it running as fast as possible, it will potentially delete all of your work. If you log out and then log back in, your work should be gone. In some cases, if you log back in enough time, it's not gone, but don't cross your fingers and just say, oh, I'm sure that'll be the case, as my work will stay. But you can then access AutoCAD through this virtual machine. Most students on Macs just prefer to use the Mac version rather than the Autodesk version, but if you are struggling with the Mac version of AutoCAD and you think it might be easier for you to be able to use the exact same Windows version that I am, feel free. The other thing is that I did mention a little bit before when we were just looking at the softwares, is that Revit is not available for MacBooks. So if you do have a Mac, you cannot download Revit on there. You'll either have to use it through Autodesk or download something like Parallels to put your own virtual machine on your computer, or use Boot Camp to partition your hard drive to make part of your computer a Windows computer. We'll go over that more when we get into the Revit stuff. But Revit is a Windows-only software. And of course, too, there are computer labs in Catherine Harper Hall that you can go to Catherine Harper and you can use them too. So if you would rather just go directly to Catherine Harper and just use some of the desktops in there, there are 2 computer labs. There's one in what I would call the basement, so right in front of where the elevators are on the very first floor. There is a computer lab there, and then there's one on what I call the 3rd floor, but it's technically the 2nd floor of Scott Kerr, all the way on the side where the parking deck is. There's a computer lab there that you can also feel free to use. Okay, now that I've rambled on just about that for 30 minutes, let's look at what AutoCAD is. And so when you first open up AutoCAD, if it's for the very first time, you might not see this Get Started screen. You may be just launched directly into a blank drawing, and that's just fine. But every other time you open up AutoCAD, you will be greeted with this Getting Started screen, in which it'll have all of the documents that you've recently opened. So for me, it's mostly just my students, my high school students' work that they were turning in so I could grade it. But I'm just going to get started with a completely blank drawing, and I'm going to get rid of some things that I automatically add to my drawing. And I'm also going to open up with a completely blank template. So if you just click on Get Started, it'll bring you here with no settings, nothing changed. Because I had a template file I was using with my students, it had a couple of different settings changed, so I wanted to just open up with completely blank. Not that you needed a description for that, but just so you don't think you have to come in here and open up with templates or anything. And I'm rambling now, so I'll stop. Okay, so I have right here is my drawing space, and what I'll describe AutoCAD is as just a big endless sheet of graph paper. So this black gridded area here is just one big empty sheet of graph paper. If I scroll, I can zoom out or zoom in. Don't get too caught up on the grids themselves and like how many boxes is equal to a foot, purely because the grid doesn't really mean a whole lot, especially when it comes to architectural drawings. So I almost always suggest students, particularly with architectural drawings, to turn the grid off, which you can do right down here, and then the grid just goes bye-bye. If it really doesn't bug you, as long as you just keep in mind that those grid boxes don't really have any significance denomination-wise when it comes to our drawing, you can keep that grid on. I'm going to turn it off, and the other way I could turn it off is using the function keys at the top of my keyboard. So if I hit F7 on my keyboard, the grid turns off as well. So anytime these buttons are blue, it means that they're on. If it's gray, it means that they're off. The next important piece to kind of go over then is our command bar at the bottom of our screen. And so AutoCAD uses something called dynamic input, in which everything I type gets fed into that command bar automatically, and it is always prompting me for what should I do next. So we can see that when I click on turn the grid on, turn the grid off, that command bar is telling me the grid's on, the grid's off. Everything I do, so if I click on one of these commands up here, everything I do is fed into that command bar. So I clicked on the tool called line, and now it's saying that I'm in the tool called line, and I should specify where I want the first point to be, and so on and so on. And I'll hit escape to end the command. Anytime you want to end anything, you hit escape, or you can right-click cancel. There are lots of different ways that you can do things in AutoCAD. In some ways, that could be a little frustrating that there's like 3 different ways to end the command, bunch of different ways to start it, different ways to approach all of the commands. I'm just going to mention some of the different ways that you could do it, but I personally have ways that I'm most comfortable using commands, and therefore I'll probably be referencing those more often than other ones. The other thing too that I would like to mention is that I do have the resolution on my screen zoomed in quite a bit. I'm at like 175%, purely because I figured most of you guys are on laptops and you'll have sort of smaller screens, and so your toolbar may look a little bit more condensed like mine is. Some of these tools might even be further condensed together. And if that's the case, then that's the case. It just depends on your screen resolution. But ultimately, I wanted to make sure we could see what I was doing and clicking on. Now, before we get into some of what these other settings do, we'll look at some of the drawing tools that we can use. So the first one, and one of the most important ones that we will know, is the line tool. And all of these tools up here, just like the settings down here, all of your tools have keyboard shortcuts that are associated with them. So if you want to get really, really fast at using the software, then I would recommend starting to get familiar with the keyboard shortcuts and really rely heavily on the keyboard shortcuts, because you will be able to work much faster using the keyboard. But if the buttons are what provide you comfort, because you have that visual confirmation and then the text there saying that this is the line, then by all means go for it. Whatever gets you through it. So the keyboard shortcut for line is just L, enter. And because, again, that we have that dynamic input, I don't have to click down here in the command bar to type it. It will automatically feed itself in there. And the purpose of the line tool is to click somewhere to start your drawing, and then where do you want the next point to go? And so then you will move your mouse in the direction you want to go, type the distance you want, enter. Move your mouse in the direction you want to go, type the distance you want, enter. And so on and so on and so on. Distance I want, enter. Move my mouse in the direction I want to go, distance I want, enter. So on and so on and so on until I'm all done. And once I'm done, I'll just hit the escape key on my keyboard to finish the command. So what you should be seeing when you're in a command like line is there should be little text boxes next to your, or like above your line that kind of just tells you what it's doing. That's what I was talking about when I said dynamic input. Mine wasn't coming up originally, and that's just because as we were playing around in class one day, seeing what all the function keys did, I turned it off accidentally. So it is the F6 key on your keyboard to turn it on or off. Or if you click on the little hamburger down here, you can check off dynamic input, which brings this button to be available. So if I turn it on or off, we can see it popping up, popping out. And then you can just click on the button to turn it on. It's not necessary to have that text box there, but I just find it so much more helpful to just be able to type and have kind of that little drop down of commands pop up, have those text boxes pop up right next to my cursor. It makes AutoCAD so much easier and kind of user friendly. So I really recommend that you have that dynamic input on, just because it's a friendly little helpful tool. Now, if at any point you forget what a keyboard shortcut is for a command too, you can always just start typing that command out. So if I forgot the keyboard shortcut for the line tool, I can just start typing line, and oh look, I found it. And I'll specify where I want it to start, move my mouse in the direction I want to go, type the distance I want, enter. And if at any point we make a line that's too big for our drawing space, so for example, I'm zoomed out as far as my drawing will let me do, and I'll make this 500, enter. Well, when I go to zoom, I get this little thing that was popping up here that says cannot zoom further while a command is active. So that means I'll have to either hit escape to end the command, or right click, cancel, and now I can zoom out further. If I hold the scroll wheel down, I can do something that's called pan. So if I hold the scroll wheel on my mouse, I can move my drawing back and forth without changing the zoom. So I can zoom in on an area by scrolling, hold the scroll wheel down to pan, zoom out. If you don't have a mouse, you can either use the shortcut P to enter the pan tool, and then you can click to move. And once you've moved it where you want it to go, you can hit escape or enter to end it. Or you can use the shortcut here to go into the pan tool, click to move it around, escape or enter to end the command. So there are different ways to still be able to do that, but the scroll wheel makes it the easiest kind of shortcut. And another little shortcut that you can get from your scroll wheel is if you double click the scroll wheel itself, you get what's called a zoom all, which means that it zooms it to everything that I currently have drawn. So if maybe you get too far zoomed in, or maybe you scroll too far out and you can't see anything, you can just double click on the scroll wheel and it zooms you into your current drawing. For a shortcut, we can click on this zoom extents to do that, or Z space A space, which didn't change my zoom at all because I was already zoomed to the extents, but if I do Z space A space, it zooms me in on everything that I currently have. So a couple of different ways that we could find our drawing once we have it drawn. Now, one thing that hopefully you'll notice is when I'm in the line tool, as I'm drawing, I get that little green line that pops up. For me, it's at every 30 degrees. For you, it might be just popping up every 90 degrees. That's just depending on how you have that setting functioning and what you set the degree to. But what that is called is polar tracking. And so polar tracking is letting me know when I have my cursor pointed, in this case, like I said, at every 30 degrees, so that this way I can draw my lines nice and neat. So it's pretty much doing the same thing that, my T-square and my triangles were doing, but I just don't have to have those tools anymore because the computer is just doing it for me automatically. So polar tracking is fantastic. I love it. And the button for polar tracking, let me just hit escape to exit the command, is right here. It's the one that looks like a little pizza pie. Or it is F10 on your keyboard. So if I hit F10, it turns it off. If I hit F10 again, it turns it back on. If you want to change the settings that it goes to for each angle, you would click on the little arrow that's right next to it, and you can change it to different settings. So by default, usually the first time you open AutoCAD, it's set to every 90 degrees, but I could have it show me every 45. I like to set it to every 30 because once again, I do a lot of mechanical engineering drawings with my high school students, and therefore we do lots of isometrics, and 30 degrees is the degree set for isometrics. So that's why I like mine set that way. You can set yours however you want to. If you want to leave it at every 90 degrees, that's fine. But polar tracking is what I prefer to help keep my lines nice and parallel and perpendicular. The other option you have is what's called ortho mode. And so the button for ortho mode is located right next to polar tracking. It's the one that looks like a little right angle, or it's F8 on your keyboard. Now, if I clicked on ortho mode, we can see that polar tracking got turned off. So I can either have neither ortho mode or polar tracking, or one or the other, but I can't have both of them on because they're both in charge of similar tasks. So now that I have ortho mode on, I'll go back into the line tool, L, enter. I'll click somewhere to start my line, and it's only allowing my line to be horizontal or vertical, and even if my cursor is a little bit off, it will only allow me to do it just that one direction. So a lot of students using the laptops tend to like ortho mode a bit more, just because with polar tracking, you do have to make sure that your cursor stays put while you then type your distance in. With ortho mode, if my cursor slips a little bit, then it's not that big of a deal, because I'll still have that horizontal line. I personally prefer polar tracking, but like I said, if I think my cursor is exactly where I need it to be, and then it moves slightly, and I go to start typing my distance, I can't correct it, which would be annoying with a mouse on a flat surface. As long as I just know that it's in the right area, I should be okay. What I would have to do instead is hit escape, correct my mouse, then type my distance, enter. You can also switch in between polar tracking and ortho mode while a command's active. So currently I'm in polar tracking, but then I can hit F8, and now I'm in ortho mode. And the only way I could draw a line that isn't perfectly straight or perfectly vertical or horizontal is if I was to draw to what's called an object snap. So as I'm drawing, these little green shapes are popping up. And now I could draw a line at an angle to go to the endpoints of all of these different lines and things that I've put on here. So object snaps help us make drawings a little bit nicer and neater by snapping to different parts of the drawing. Let me hit escape just to end the lines tool. And the button for object snaps can be found right down here. It's the one with the little square and then the tiny square in the corner, or it is F3 on your keyboard. So we can see that object snap is off and now it's on. And also too, if you ever want to see a list of everything that your command bar has in it, F2 on your keyboard shows me all of the things I've done. So it shows me that I turned polar tracking on, and then I turned ortho mode on. I went into the line tool. I clicked to where my first line would be. I made it 45 and then 50. And then I made it 45. Again, I turned ortho mode on. I clicked to a bunch of endpoints. I hit cancel. I've turned the object snaps off, on, off, on, off, on. So that's F2 on your keyboard, or click on that little button there. The command bar is great for me as a teacher because AutoCAD is tracking every single thing that you've ever done gets saved into the file, which makes it really easy for me to know if you're cheating, because if you and another student did every single thing exactly the same and even undid things at the exact same time, then it lets me know that, okay, this is obviously not your file, this is someone else's. And it even tracks like down to the second how often you've saved, when your file started. So I'll just get that out of the way right now, is if you try to cheat in your AutoCAD work, it's going to be very easy for me to know. It happens every single semester, and every time they think there's no way she'll figure out. Let's assume I know more about AutoCAD than you right now. Hopefully at the end of the class you know just as much as me, but just try not to turn someone else's work in, because that's ultimately not too great. Little disclaimer right there. But anyway, with our object snaps, we can turn different ones on. So if I click on that little arrow, it gives me different ones that I can have turned on or off. I like to have the endpoints, midpoints, the centers, the intersections, the extensions. These other ones are helpful, but I don't need them very often. Sometimes I even won't have that midpoint one turned on, because the other ones I still can get while I'm making drawings if I need to. So, for example, if I close out those snap settings, and by the way too, if you're ever curious about what some of the symbols are on the drawing, if you click on that little arrow next to object snaps and go to the snap settings, it'll give you kind of a a key or a legend about what the different symbols on your drawing and what they mean. So the squares mean that it's an endpoint. If it's a triangle, it's a midpoint. Circle is a center or a geometric center. So a geometric center would be like the center of a rectangle or a something that we made using the polyline tool. Quadrants would be the 4 north, south, east, west points of a circle. Insertion point would be for like blocks and text and things like that, and we'll go over what most of these things are as we get through the software itself. But anywho, I'm going to go back into the line tool, so L, enter, or, and here's another tip too, the space bar and the enter key do the exact same thing in AutoCAD, no matter what. So I could hit enter or I could hit space on my keyboard depending on which one I wanted to do. And I can just click on an endpoint to start my line, click on another one for where I want it to go next, another one for where I want it to go next, and another one, and another, and I could just keep going from endpoint to endpoint if that's what I wanted to do. If maybe I wanted an object snap that wasn't popping up, so for example, I turned midpoints off, but now let's say I do want the middle of this line. The issue is that anytime I see one of those green shapes pop up, so for instance, my cursor is nowhere near that point, but because that shape's popping up, if I click right now, it's going to snap to that point. So if I want the middle of something, but I don't have that object snap set to come on, I can hold down Shift and right click, and that gives me this menu of snaps that I can refer to, and now I can say midpoint, and now it will only show me the middle of lines. So now I can only go to the middle of things. And so that's Shift, right click, midpoint, and now I can only go to the middle. Or if I had circles on here, I could make it to the centers. I could do it to, a lot of times I'll use that for the tangent tool, but I can really kind of just change up what those different snaps do and what they are. There's really, in my opinion, no reason to turn object snaps off. So I always recommend to have at least your cursor to either polar tracking or ortho mode, depending on which one you prefer. I like ortho mode, but to just have your cursor completely free without having any angles that it tracks to is, in my opinion, not a good idea. And you can just turn object snaps off altogether. But again, I think they're more helpful than harmful. So I would personally keep them turned on. Let me just click to turn it back on. Another thing that object snaps can do really handy or handily, I don't know if that's a word, anywho, is to kind of track to snap points. And what I mean by is if I hover over an object snap without clicking, I get a little set of crosshairs, and then it'll show me where 2 points could intersect each other or extend out from each other. And so because I have polar tracking on, it's saying that, hey, if this vertical line continued up, this horizontal one would meet with it right there. And so that can be very helpful in architecture to just kind of see like, okay, well, if I want these two doors to be aligned with each other, I can just kind of figure out where the two pieces would be aligned with each other. And we'll see that in the next video where I kind of go over the demo of just a little house project that we're gonna practice with. And of course, escape to end the command. Now, last thing before we jump into more of these drawing tools and just what some of they do is making selections of stuff. So I can click on lines directly or click on any drawing feature directly and select it that way, or I can draw windows for my selections. And depending on which way I go is what type of selection I have. If I click and hold, I get this lasso thing, which students love. And honestly, this is the one thing I'm happy about not being in person for with this class, is because usually when I introduce this, I just see this mess, this Picasso mess on every student's screen, and it just drives me bonkers because I know no one is listening to anything that I'm doing because they're just sitting here going like this over and over again. And I won't deny that this is fun. This is fun. I'm not going to pretend it's not. But I don't like the lasso tool. So if you click and release, you get a nice friendly box version. But you can also click and drag around objects. And just to kind of show you what those two different selection tools do. So if I go towards the right, I get what's called a window selection. So this blue box is a window selection, which means that whatever I want to select has to be entirely inside it to get picked up. So we can see here this line, this little diagonal one, isn't highlighted until it's entirely inside. And so it has to be entirely inside the window or the lasso that you make to get selected when it's the blue version. If I go towards the left, I get what's called a cross selection. And with a cross selection, it only just has to barely touch it to get selected for it. So the cross selection is good when you need to just make a big selection of stuff right away, real fast. Window selection is better if you need to be a bit more precise of what exactly you're picking up. Now, all of these little blue dots that pop up are what we call grips. And we can click on those grips to move things around. We can click on them and move them. So like, since I have polar tracking on, I can extend this out 20 more, or I could take it and I can make it 10 less. I can click on the midpoint one to just move it entirely. So your grips can be useful to just kind of quickly move different points or features around. I don't rely too heavily on grips. And that could be because when I first learned AutoCAD, being able to move and stretch and do things like that with grips wasn't really a thing. And so I just got very used to not doing things that way. That's why I think maybe I don't use them. But if they work for you and you find them helpful, then by golly, use them. I wouldn't show you that they existed if I thought it would be bad for you to use them. And now, of course, one of the most important commands of all, the erase tool. So to erase things, there's a couple of different ways you could do it. So once you have everything you want selected to get erased, you can highlight all of it and hit the delete key on your keyboard, and it erases it. So we can see that my command bar says that 23 objects were erased. I'm going to Control Z or Command Z if you're on a Mac to undo. And I'll just highlight everything again. The other way I can erase it is to right-click, erase, does the exact same thing. I'll Control Z to undo one more time. Select all of my stuff. And then I could also use, if I want the button, that's the erase button right there. So all three of those ways do the exact same thing. I like the keyboard shortcut of the delete key. But do whatever works best for you. But as a side note, and this could be different for Macs, the backspace key is not the delete key. So the backspace key does not delete things automatically. But it could be different on Macs. I am not sure. It has been many, many a year since I've used a Mac. But Control Z or Command Z is the undo command, and it is very helpful to be able to undo things, especially after you realize you erased way too much. All right. So now, before we dive into the rest of these drawing commands, let's set the units for our drawing so that this way we are working in feet and inches. And so just like with all of the tools at the top having multiple ways to get there, there are multiple ways to get to changing your units. One way would be to click on the big red A and go to Drawing Utilities and then Units. So I just hovered over Drawing Utilities, I didn't click. And then I can click on Units, and that'll open my unit menu. The other way is just to type in units without clicking on anything. You just type in the word units, it'll open up your drawing units. And so AutoCAD by default is working in just decimal units, and it's not necessarily inches, feet, or millimeters. Right now it's not set to any particular why can't I think of the word? Measurements system. System was the word I was struggling with. Even though here it says the insertion scale is set to inches, that just means the blocks that we bring in are set to inches. So it doesn't mean that our drawing right now is set to inches. But we're just in decimal type units, and we're going to switch it to architectural, which now means that we are dealing with feet and inches, which is what we want. And we can set this precision to be a different amount if we want to. I'm just going to leave it set to 1/16 of an inch because that's just more than fine for what I need. And I'll click on OK. And now when I go into the line tool, so L, enter, and I click somewhere to start my drawing, we can see that in that text box now, instead of it just being like the number 400 like it was before, it is now reading feet and inches out. When you are typing your units or your measurements in AutoCAD, it is going to just infer that you mean inches unless you tell it otherwise. So if I just type in 12, enter, it made that 12 inches long, not 12 feet. So if I want something to be 12 feet, or I'll extend this line 12 feet longer, I need to put that single tick mark or the apostrophe symbol after what I type. Enter, and now that line is 12 feet long. If I want to type in something that is a combination of feet and inches, so for example, I'll do 4 feet, and then I could continue by typing in 5, and I could put the inches symbol, which would be the quotation marks, not 2 apostrophes. So do not type in 2 singular apostrophes, because then it's going to tell us, it's going to highlight it red, and it's going to say, I don't know what the hell that means, because you just said 4 feet, 5 feet, feet. So it needs to be the quotation mark, or I could just type in 4 feet, 5 without any unit annotation after it, and it is going to infer that 5 feet or that 5 means inches. If I have fractional inches that I need to put in, so I'll do 5 foot 7.5 inches, I would type in 5 foot 7-1/2. So this is not like SketchUp, in which that dash is going to be referred to as subtract. That means that it's 7.5. I could also do 7.5, and that would work out. The reason why I can't put a space in between is because the space functions the same as the enter key. So if I do 5 foot space, well, now it just made a line that's 5 foot. It didn't make a line that was 5 foot 7.5 inches. So you can't put a space in between as you're typing. If you wanted to do So let's see if I do it like this, 5 foot dash 7 dash 1/2, quotation mark for the inches, enter. Okay, so you can put 2 dashes in there, but to me that's kind of overkill. I usually leave that dash out in between the feet and inches when I'm typing in my measurements. And so now I have my units of my drawing set, and just make sure as you're typing, if you are typing in an amount that is feet, make sure you type in that foot mark. Let me highlight all of this, and then I'm just going to hit delete on my keyboard to make it go away. The next tool that we'll use fairly often is the Polyline tool. And so the Polyline tool is great for architectural drawings, and I'll do 2 shapes, one using line, one using polyline, just so we can kind of see the difference of why I might prefer polyline over the other. So if I go into the line tool and I just draw a box that is 6 feet, enter, by 6 feet, enter, by 6 feet, enter, and then I'll just click up there to end it and hit escape to end the command. So with the line tool, these are 4 separate lines. They exist completely on their own. If I do the same thing using Polyline, which is keyboard shortcut PL, and I'm going to just hover over that endpoint just so these start lined up with each other for really no other reason. And I'll do 6 foot by 6 foot by 6 foot. And then I'm even going to put C to close rather than click to close it, and that just exits me out of command. With the Polyline tool, this is all one connected piece versus this being separate pieces. The other benefit for Polyline, and so if I go back into the command, PL, enter, and I'll just hover over that just because I like to have my examples lined up with each other, is that I can switch myself over to the arc command in the middle of it. So if I had something where I needed to put a curve on it, and then I could switch myself back over to the line tool, 6 foot, C, enter to close it. And this is all still one combined piece. When we look at some of the modify tools a bit more, we'll see how I could get that without doing polylines. I could do that with just lines and circles. And then the trim tool, my favorite tool of all of them. And we will go over some modify commands today, but I just don't want to do too many of them today. So I can get this end result. I could also get this from this, but ultimately it's kind of dependent on just how much work I want to put in and how many extra steps I want to put for it. And so sometimes just starting with polyline is more beneficial than taking lines, joining them together, and things like that. So the benefit of polyline versus the line tool with architecture really comes from our wall thicknesses. And so within our hand drawings, we had to show how thick all of our walls were. And in AutoCAD, we break that down even more because not only are we showing our overall wall thickness, but we're showing the thickness of every layer of that wall. So that exterior wall in that small house project was not just a single material that was 7 1/4 inches thick. It was a piece of siding on the outside, then a piece of sheathing, then our stud, and then our gypsum wall boards. So there were several different materials that made it up. In AutoCAD, we would show all of those materials in there. And rather than drawing out every one of those lines, which we could do, it wouldn't be incorrect, it would just be kind of time consuming. We instead would use a tool called Offset, which is located right here, or keyboard shortcut O. And the way the offset tool works is it'll make a copy a specific distance away. And I can either type my distance that I want it to be beforehand. So I'm just going to make this a 7-inch thick wall. So I'll just type in 7, enter. And then I can click on my line that I want to make a copy of, click on which side I want to put the copy on. Click on the line I want to make a copy of, click on the side I want to put it on. Line I want to make a copy of, side I want to put it on, so on, so forth. Or with a polyline, if I click on it, it'll automatically clean up all my corners for me, which is ultimately what I prefer it to do. And then escape to end the offset command. Another feature of offset is that we can do this option for through. And if I use the through option, I get to define that distance as I go. And so I can click on my object and say I want to go in, 0.75, enter. And then I want to go in 0.5, enter. And then in 5.5, enter. And in another 0.5, enter. And then escape. And I've got all of those layers of my wall done a lot faster. I'm going to demo this in several videos, so don't worry about not having it automatically. If I did an offset with this through option on here, which furthermore, just to kind of go on what's going on here in my command bar, is anytime I have those grayed out options, those means those are buttons that I can choose or options that I can click on. Additionally, if I type in the blue piece of text, so for through it's a T, for erase it's E, for layer it's L, those are kind of blued out. Those means that that's the keyboard shortcut to go for that option. And then anytime you see something in those triangular brackets, it means that that's the default. So if I don't type anything in or click on any of those options, it's going to assume I want through. Just for the sake of a demonstration, I'll type in 3, enter, and I'll just take this and offset it out 3. And then I can either hit enter or escape or the space bar to just leave the command. And then if I go back into offset, O, enter, now in those triangular brackets, it says 3. So that means that's the very last option I chose. And AutoCAD is assuming, unless I tell it otherwise, that that's what I want to do again. So unless I tell it, no, I want to do through this time, so I'll do T, enter. And now I can go and click on these lines, and I could, for this one, I could bring it in 0.75. And then bring it in 0.5. Bring this one in 5.5. And then bring it another 0.5. Same thing over here. So I could do this on every single side. Oops. 5.5. And 0.5. I could sit and do it that way. Nothing wrong with doing it this way, but it's just more work than if I was to do it this way. Because I still could clean these corners up by either highlighting them and like clicking on these grips to shrink everything down. So I could zoom in and click on this grip and like bring it to, I guess that one goes to there. This one would go to here. This one would, no. Oh wait, actually one of these would get erased, but anyhow. So I could sit and change my grips like that. I could also use a tool called Trim, which is keyboard shortcut TR. And what Trim does is it allows me to just kind of go in and clean up where all of these overlapping lines are, so I can just click on the lines that I want to go bye-bye and make them go bye-bye. Even though I've got an extra layer there, it's still, you kind of get the idea. And so that's, again, TR for trim, enter, and I can just cut lines to meet at their next closest point. But that's just extra steps from what I got automatically with a polyline. So polyline tends to be the tool that we prefer in architectural drawings, or at least that I prefer in architectural drawings, just to be able to make things a little bit faster as I go. Now, the next very important tool that honestly we don't use a lot for architecture, but it's important and you should know it, is the circle tool, which it's keyboard shortcut C, or the button is right here. And anytime you see a button with a little arrow either next to it or underneath it, that means that there are different options available. So there are different types of circles that I could draw. I could do a circle based on its center point and radius, its center point and diameter, on 2 points, 3 points, base it off of tangencies. Depending on where I want the circle to be and what I know about it, I can set it up different ways. So if I click on any of these options, so I just said I want to do a circle radius, the first thing my command bar is prompting me is to specify the center point of it. And then it's also giving me some of those grayed out options again. So it's, even if I went into the circle tool and it wasn't the one that I wanted necessarily, I could still switch myself over. I'm just going to put it over here. And now it's asking me to specify the radius. So I would type in what I want that radius to be. Or I could type the letter D, enter to switch myself over to the diameter tool. Or I could click on that diameter in there. So if I wanted the diameter option, I could just switch myself over to it. But I'm just going to give this a radius of 36 inches. So I'm just going to type in 36 without any annotation, because it'll automatically infer that I mean inches. Enter, and then it makes a circle that size. If I go back into the circle tool, so I'll just do C, enter, and I specify a center point for it. So I'll just say I want, its center to be here. We can see again in those triangular brackets, it has 3 feet. So that means if I just hit enter without typing anything in, it is going to make a circle that is 3 feet. So anytime you see those triangular brackets, it just means that was the last thing you did, and AutoCAD is going to assume that that's what you want to do again. The other types of circles that can be beneficial is, especially this one I really love, is the tan radius, where you say I want my circle to be tangent to this line, tangent to this line, so I'll click again and have a radius of 24, enter, and it'll find where that circle would sit center point wise based on being tangent to those 2 lines. So I like that tool a lot. It works really well with product design things. There is also another kind of modify shortcut that we'll go over next week. I need to just re-verify with the schedule, particularly because I did change some things around in it. But yeah, that's the circle command. We don't use it a whole lot in architectural drawings, just because we don't make circular things too much. The arc tool, so we can use the arc tool to help make our door swings. I personally just do not use the arc tool. I like to draw circles and trim them. but there are lots of different types of arcs out there. So based on what you know about it, so if you know where its start point, its end point, and its radius, or its start, its end, and then the angle it's at, start, end, and direction. So based on what you know about it is what we can kind of help to create our arc, which we'll see in the next demo. But ultimately, I tend to just make circles and trim them down. So I like to tell students that you really can make absolutely anything you need to make in AutoCAD using just line, circle, and trim. Every other tool that is in here is just a tool that we can use to speed the process up while drawing. But ultimately, if you are stuck, line, circle, trim. Those are the only three that you need. Every other one of these just helps us work a little bit faster as we go. So next up then is the rectangle tool, which also, if I click on that little arrow, doubles as the polygon tool. Now, the keyboard shortcut for rectangle is REC, enter. And with the rectangle tool, you click where you want it to start, you move your mouse towards the direction you want to go, and then you'll type in your length or your horizontal measurement. So I could type in 24 feet, and before I hit enter, I'm going to hit tab on my keyboard, which will now let me type in that vertical measurement, 12 feet, enter. This works like Polyline in that it's all one connected piece, and so this way, if I was using the offset tool, I could bring it out and in without having to worry about cleaning up the corners. So it can be pretty helpful for that. Now, the polygon tool, the way it works is the first thing you need to do when you enter the tool is say how many sides you want your object to have. So I'll start with 6 sides, 6, enter. And then it wants to know the center point, and I'm going to do it centered on this circle. So I'm just going to click on that snap. And then it wants to know size-wise, is it sitting inscribed inside the circle, or is it going circumscribed around the outside of the circle? So depending on what you know about it, the shape in relation to the circles, you would click on either of these options. I'm just going to say it's inscribed, and I'll just make it 3 feet or 36, enter, inside that circle. And I'll do another polygon, which is POL, right? Yep, POL. Enter. Because the last one I made was a hexagon, AutoCAD is assuming that I want to do another one with 6 sides. So I'll hit enter again without having to type anything in. This one I'll center around this circle, but instead I'll make it circumscribed with 3 feet, and now it's sitting outside of it. So with a circumscribed, we're measuring from flat to flat. So it's 3 feet from the flat of the shape, the polygon, to the flat of the polygon. With inscribed, we're going corner to corner. And that goes for any shape as long as it is a regular polygon, which means that all of the sides and all of the angles are equal. If it was irregular, well then that kind of goes out the window. Some other drawing tools before we get into the last drawing tool of today, which will be the hatch tool, are located underneath the word draw. So if you click on draw, you get menus of some more tools available. In the Mac version, those tools might be pretty readily available to see, but there they are. So the spline tool, I'll use a lot if we're doing some type of design that is either requires my students to trace something out or to make something ergonomic, where it's kind of more organically shaped to be a little bit more friendly for like a human to interact with it. But the spline tool, which is keyboard shortcut SP, what the spline tool does is it allows us to, like I said, make some more kind of organic-y looking lines or shapes. The difference between spline and any other drawing tool is you do not hit escape to end it. If I hit escape, it deletes it without saving it. And so if I go back into the spline tool, the more points I add, the more points I'll have to deal with later. And I'll just pan myself over a little bit. To end the tool, I want to hit enter on my keyboard, and that ends the tool. Now all of the grips on here I can manipulate further. So if I had something that maybe I wanted to have a little bit more of an organic shape or feel to it, I can use spline for that. There are two types of splines. So this was a spline fit, but there's also a spline CV, which is referring to those points or those vertexes. And so with a CV one, your points that you're referring to are not directly on the spline itself, but they're rather off of it a bit, but you still would hit enter to finish it, and you still can click on it and change them as you go and draw. Not really all too popular for architectural drawings, the spline tool, but you may encounter it. You may have a need for it at some point. And then SP is its shortcut, or SPL is its shortcut rather. And you can also click on things out of this little menu, out of this dynamic input menu for shortcuts. All right. Another tool that I'll use kind of often for architectural drawings is a construction line, which is keyboard shortcut XL. And it just will help me kind of align my different views. So when I'm looking at my floor plan and I just want to project guidelines down for my elevation, I can use the construction line tool for that. And so what it does is if I go to a specific endpoint, it'll create an endless line segment from that point. And so XL to get into the command, and I'll just go from that one, and I'll do it at a couple of different angles. And then escape to end the command. And if I zoom out, it makes just this endless line segment. Remember at the very beginning when I introduced AutoCAD, I just said it's this big endless sheet of graph paper. And that is essentially what's going on here. One of the drawbacks for construction lines, which, oh, they fixed that. That's so cool. It used to not be able to do that. So one of the drawbacks was if you tried to do a zoom all by Z space, A space, or double clicking the scroll wheel or doing extensive drawings, it counted those construction lines as part of the extents, and therefore it would like freak out and just not be able to compute. But they've changed that. That's so great. I don't know what year they must have changed that in. They do very small, tiny little updates to AutoCAD every year, but they really don't change a whole lot to it. I'll just delete those because they're going to bug me. Like, for example, the big change from 2019 to 2020 was that the trim tool highlighted what you were doing beforehand before you clicked on it to actually get rid of it. That was the big difference. You know, which is kind of crazy to me that it took 40 years for them to figure that out, but hey. So yeah, that construction line tool can help me make real quick guidelines, so that way I have to measure a lot less when I'm projecting for either maybe not really a second story, because I would just copy the first story for that, but if I was to be trying to do my elevation views, I don't have to take those measurements at all. Or if I was making an orthographic of a more complicated object, I can just kind of project those features up and then play around with them. Raise would make the same thing, but it would just go in one direction. So rather than it going both up and down in this case, it's just making an endless line segment that goes downward. So some students, they prefer the rays over the construction lines. Many students won't use either, and that's fine too. Whatever works best for you. And so I'm just going to click on that guy and hit delete to delete him. There's also a tool that I'll use a lot in your drawings when I'm grading things called a revision cloud. And with a revision cloud, and it's going to look a little weird probably just because the arc lengths aren't set. Yeah, so it's looking pretty big. So what I'll do is I'll kind of put a little highlighted area around like something that is a problem in your drawing, and then I'll have a little text box explaining what went wrong. But in a set of architectural drawings, this might be used to say like, hey, this has actually been changed. Go refer to sheet A502 for more information about that change. So revision clouds just kind of help show tiny differences in things. And in the revision cloud tool, which you can also kind of freehand them, or I just leave it as rectangular, you can change those arc sizes. So if I go into arc length, which it makes me think like I have already set it at some point, if it's that large. But I can, just have it be 2 inches. And now like they're really tiny ones. And so if at any point they're too tiny for your drawing itself, you can just change that arc length amount for it. And then finally, the last drawing tool I'll tell you about today, or rather in this video, because a lot of you watch them both in one day, which is fine by me, as long as you're watching them and trying, is the hatch tool. And so hatch is keyboard shortcut H, or this button right here. I know in the Mac version, it is like its own separate little segment, and that it does work a little differently in that Mac version. So for those of you working on the Mac, bear with me, and I will try to find a good YouTube video that goes over hatch on the Mac version, and I'll link it in the description of this video, just because I do know it works fairly differently between the two of them. So the hatch tool completely changes our toolbar and opens up a very different menu in which we can play around with our different hatches. So we can change our pattern of our hatch, and then we can also change properties related to it over here. And so if I hover over a closed area, it'll give me a preview of what that hatch would look like in that area. And if I click, it fills that area in. The problem I see happen 99% of the time in architectural drawings is when I ask students to do a solid hatch and they fill it in with this is not solid. If I zoom in to it, it's actually doing diagonals. It is not solid, it's diagonal lines. Not what I want. I want it solid. When I zoom out, yeah, sure, that looks solid, but it's not. And so that would be changing this pattern here to just say solid. But while I'm still in the pattern, we'll just look at some of the things that we can change about the pattern with it. So we can change the color itself. We can change a background color. So if I wanted this to have a background color of yellow, we can't see it right now, but once I switch some other things around, we will be able to see it. Really, I don't recommend students changing these colors here too much. I recommend keeping everything set to by layer. And if you do need to change the color, you can come into this properties and change its layer. Now, we don't have any layers in this drawing, but in our example in the next video, we will make some layers, so that way we will have layers to play around with. But if it is something where it's just one particular instance, we can change the color. We can change the scale that it's at. So right now it's at a scale of 1, and if I change it, you know, to a scale of, I'll make this 36. Well, now I can pretty clearly see that it is diagonal lines. And I can also change the angle by either rotating the slider around or typing in a specific amount. So I can type in 45, enter, and now these are just vertical lines. You can click in multiple areas at once to hatch multiple things, the same pattern with all the same settings. And so if, for example, I click on this little drop down and I can do even different or more patterns. So I'll do this concrete one, but I'm going to change my scale to like 12. I'm going to make that just down to 1, I guess, again. Yeah. So it is like the hatch pattern for concrete. Or if I wanted it to be bricks, which I would need to scale up again. Or I don't want to do any of those, but maybe if I had gravel in there. And sometimes it depends on what hatch pattern you're using and what scale you should use. So each hatch pattern will have kind of a different scale that would be best suited for it. But rather than drawing all of those hatches into different areas, you can just change the hatch itself. To do different patterns, you do need to go in and out of the tool. So if I just click on this hatch and say like, oh, well, I actually want this to be concrete and these other pieces to be gravel. The problem is, since they're all done all in one command, which, go away, little thing, they're all going to change together. So I can't just change just one of them. Because I did these all together, I'll change the angle back to 0 too. They're all going to update. To get out of a hatch, I can either hit escape or click on close hatch editor here. But if I wanted separate ones, I'll go into the hatch tool separately, and now whatever I do over here has no effect with these ones. So I can change the color and it's not going to have any effect on the other ones. So, and then escape to end the command. So I always recommend that students do hatches separately, so that way if there is something that needs to get adjusted or fixed, you don't necessarily have to go back and redraw everything. Because let's say I needed this circle to actually be a different size. And so I click on, or actually let's do this one. I click on this circle and I could either double click on it or I can right click properties, and that opens up this properties bar, which it starts off as this floating thing up here, but you can drag it on the side. I like to just always have it open here. That's partly because my students are practicing, my high school students are practicing for a certification test, and all of their answers come out of the properties bar. But what I can do is if I got this circle selected, it's telling me here that it has a radius of 3 feet. And let's say I wanted it to have a radius of 4 feet. Well, that's weird. The hatch usually doesn't update with it. That must be a new thing too. That's nuts. Could also click on these grips and change things around. Whoa, that's definitely a 2021 update because that never would happen before. It's proven me wrong. But anywho, what if I change this? Oh my goodness, the hatch updates with it. So that could be no longer a problem anymore. I'll have to play around with that some more. But what I was trying to say was if I have to move this line, okay, maybe it's just because these are like polylines and things. But if I move this line around, the hatch didn't move with it. And so then I would have to change it. The issue would be then is that I change this up, and if this hatch was linked to these other ones, now I would have to go back and rehatch 4 things rather than just redoing one of them. So I always recommend just doing kind of just your walls as one hatch, just your elevation of one of your views as another hatch, then go into the other elevation and hatch it, then go into the other one, rather than having them all linked as one continuous all similar patterns in just one go. Because if things do need to get changed, then you have to redo multiple drawings rather than just redo one of them. And with that, that's kind of a brief introduction to using AutoCAD and using some of the drawing tools and a few of the modify tools. In the next video, I was just kind of a little walkthrough of a small 10 by 10 building and how we can use all of these different tools in function. And so you can feel free to watch that one as you go through the project yourself, pause me as I go through it, and hopefully you learn something. I've never taught AutoCAD as a completely asynchronous thing before, but by golly, I do love this software. I love it so much. I've been using it for more than half of my life, which is kind of weird and terrifying to think about. But oh my God, it's so cool. You can do just the best stuff in the world with it. And with that, I'll see you in the next one. Bye-bye.